Hey guys, what's going on? Richie from Photons Across the Air. So I want to show you guys something really cool, a little experiment that I tried a long time ago actually, but I made a video and I forgot about it, but I deleted it. So it's actually a pretty cool experiment that you can try at home if you got one. If you got a blue laser and a flashlight, which if you are a laser enthusiast, you have both. So now this little experiment shouldn't come to a shock, even though it's rather pretty neat. Because Wicked Lasers had this idea a long time ago. It's basically how they use on their, the Wicked Lasers Phosphorus series. They have an attachment called the Phosphorus, and what it is it's a little attachment that goes on top of the actual diode. I don't believe there's a focusing lens on there. I think you take the lens off and put the Phosphorus lens on there, or adapter on there, or attachment. Anyways, and what it does is it fires a laser directly onto that LED and excites the electrons, or it forms electrons, and basically lights up. So that's kind of what I have here. We have I don't want to roll it over because it's in a very specific spot. But anyways, that's a 1200 milliwatt laser, or 1.2 watts. And this is just a regular flashlight. Remember, there's no batteries in this flashlight at all. This is just a Nikkor EC25. You will not damage your flashlight by doing this as long as you don't have it focused. If you have the beam focused outward, a large beam, then you definitely won't damage your flashlight. But it's pretty cool because LEDs and laser diodes kind of work the exact same way, and since this is an M140 based diode, or A140, anything's possible with what sci-fi used to do, but probably an M140. But anyway, since this is a semiconductor based laser diode in here, and that is basically a semiconductor LED, there's a P and an N junction pretty much. They pretty much work the same way, except for one's coherent light and the other one's not. So anyways, so we're gonna fire the, by the way, I have a crappy acrylic lens on there because I took the 3 element off and put it on something else. So I have an acrylic lens on there. Somehow I'm getting 1.2 watts with an acrylic, but anyways, let's get to it, I'm sorry. So anyways, as you move the laser over the flashlight, it emits a very bright white light, or a very bright light as if the flashlight is actually on. And it's actually pretty cool. It's actually a really neat experiment. And when you shine your laser directly into your flashlight, it's reacting with that LED in there even though there's no power source, and it's exciting the electrons and basically causing it to light up. Now, I'm not 100% expert on this, but I know the simple basics and how it works, but it is pretty cool. So something really cool to try. Got cat hair everywhere. Okay. Yeah, so you move it away, it's off. Now, if you focus your laser, it's going to get a lot more intense, but it's going to burn up your LED. So, really cool experiment. I thought I was one of the first ones that had done it until I had actually forgot about the Wicked Lasers Phosphorus attachment, and that's pretty much the exact same thing they're doing. And a long time ago, when they released the Phosphorus attachment for the Wicked Laser Arctic, I was trying to figure out how it was possible. I don't know. I was trying to figure out how you turn a coherent 445 nanometer light, which is basically just pure blue, there's no white light in a laser of 445 at all, how it could turn into a white flashlight, how it could turn into a bright LED flashlight. I couldn't figure out how it was done until I actually got to looking at it, some pictures online, and realized that's basically what they're doing. They're just taking full advantage of the fact that laser diodes and LEDs pretty much work the same way. A few differences, but they do pretty much have the same principle, concept, and how they emit light. So anyways, so try this at home. It's definitely a really cool experiment. Make sure the laser is unfocused. You don't want it focused in because, if you don't have glasses on, or, you might burn up your LED also. So, but yeah, definitely really cool. It's neat. And it looks like the flashlight is actually on. In fact, it's actually as bright as it would normally be if I had batteries in there. Now, if I take the laser and I move it closer to the flashlight, it'll actually get a lot more intense, a lot brighter, but then we're going to end up concentrating the beam a little more, and I don't want to damage this flashlight, so definitely pretty cool. Red actually doesn't work with red. I've tried it multiple times. In fact, I have an Oclaro 700. I might test it later to see. When I conducted this experiment, I didn't have anything more than about 125 milliwatts of red, so anyways. Alright, so now that you guys have seen that cool video of how the laser diode from this, or the LED from a flashlight, can absorb the radiation or energy from a laser diode and power the LED, in theory, I guess. So now it's time for the destruction of a flashlight. This is an old Dorsey flashlight that I got a long time ago, and we have the 1.2 watt sci-fi. So, I'd say it's about time for the destruction of a flashlight. This ought to be interesting. I'm trying to figure out if I want to put the laser glasses on me or the phone. Anyways, figure it out, I suppose. Unfortunately, I don't have any glasses for myself and the camera both, so I'll have to make a sacrifice here. Obviously, it'll be the phone, so. Now before you guys say, hey, are those cheap eBay ones? No, I got these from Dragon Lasers, so. Alright, so we'll set this up. We're going to destroy this old Dorsey flashlight, and definitely not destroy the $250 through night sitting over there. Alright, set it up here. Okay. I think we are definitely all good. There we go. I'm not sure how it's gonna look, but and there goes the laser somewhere. I'm not exactly sure how that turned out, but looks like it didn't do much. I think it might be time to hit it again, don't you think? Yeah, it's very unsafe of me to do that with no glasses on, so let's do it again, but let's focus it this time. Hair point. Alright, you guys ready? Let's do this. Let's really hope I don't damage my camera. Oh man, it's not looking good. Wow. Didn't do as much as I thought it was going to do. Huh. Still, damaged it pretty good. Interesting. It was actually hitting the LED right on the die there. I don't exactly know why I didn't burn up the LED.